Test 1, 2. All right. Let's make my face bigger. Cool. All right. Let's do some Rust today. All right. We're going back to the K to HTTP project. And I'm going to just head over to that. Let's open up tmux. All right. Rad. Okay. So we built the CLI. We can close this too. We built the CLI. We rushed through creating a controller, but we just started doing that, didn't we? I think. Controller, cargo, blah, 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 blah. Okay. CLI crap. Yeah, nice. Okay. I remember stealing this from some blog post somewhere. We did some cargo finagling, didn't we? I think. Yes, workspaces. What is this? Case. None of the V1 features are enabled on a Kate's Open API crate. Kate's Open API crate. Part of the feature to be enabled to indicate which version of Kubernetes. Okay, I know where to go to get that. The same place that a lot of this code is stolen from. Where are you? Kate's Open API, default features false. That's what I need. And then version 0.9, we'll see about that. And oh, we have that already. Do we? Why don't we? Why doesn't that work? They have kube. Do they not have kube? They don't. How about that? How about that? Is that gonna work? We'll go down there. Cargo build. Hanging on Kate's Open API. Just like all other languages, this SDK is probably massive. Because why not for a REST API? Can't find crate, sur derive. Okay, so these are compile errors, that's fine. Unclosed delimiter main.rs line 89. Okay, sweet. So we can do stuff. Haha. What's up with that? Function handle. Unclosed delimiter? Is that because we fucked up something here? Weird. Debug. Maybe we need to print. Still unclosed delimiter? Weird. Something is weird here. Oh, there's already a function main, and this is all fucked up. Okay. This is fucked up. Wow. Oh boy. Okay. Let's check out what the hell I did. I don't know where I copied stuff from, but let's see. Is there main.rs in here? Pod, spider, one click. How about that? Smite all integration test pods. Smite them all. Alright, well, we're gonna just comment some stuff out here. Not that. Function main. Function main. Alright, so I think we can shake. I think we still need the macro use, probably. Kube, use kube all the things. Probably move this down. Probably. Okay, that's a little better. Now what are you going to complain about? I know you're going to complain about something. Can't find crates. Surd derive. Do we have surd in here? No. We probably need to bring that in. Duh. Surd derive, surd JSON, and surd. Okay. Okay. Cool. 10 errors. You might be blah 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 blah. Okay. Unresolved import kube. Is that because I commented? Yeah, that's because I commented that out. Okay. What's going on here? Blah blah blah. It requires a feature. I get it. If you're using OpenAPI in a binary crate, enable the feature corresponding to the minimum version of the API server you want to support. Your binary crate might not directly depend on OpenAPI. In that case, add it to enable the feature. If you're in a library crate, I am not. So I'm not in a library crate, but I am adding the feature. Am I not? V something. Yeah, V1 underscore. I am doing that. Maybe I need to get rid of this. And we will take out default features. Okay. So when we have kube in here, let's take it out completely. Who knows? I think you need that, but I don't know for sure. Okay, Kate's OpenAPI. The cargo lock has it in there still. It should not. It should not. 118. This does not have the kube thing. Do we let's check out that link again. There's a link somewhere in here. Writing a controller in Rust. Here's the kubelet. Here's the doc. Here. Okay. What are y'all importing? Kube. Okay, so kubelet. Cargo.toml. Async trait, blah, blah, blah. Kube runtime, OpenAPI. Okay. Interesting. All right, so they've got 118 version 0.9. They have a runtime. Oh, and they're specifying default features false. Okay, let's take that and see what we got going on with that. All right, what you got for me? Kube. API object. Okay. Okay. So API object exists. Raw API does not exist. And then here, blah blah blah. Kube. They don't have Kube API. They have that. Do they have a void? Yeah, they have a void. Where's the void? Are they not importing void? I suppose they're not importing void. Okay. Is void is something else, huh? Okay. Are we gonna... I think we're gonna finish with our dependency resolution. Maybe? Maybe? Come on. You can do it. Okay. Okay. Lots and lots and lots of shit. Okay, we're gonna just go past that. Request identity, that's in Kube. So this is all inside of Kube. I guess we need request in our dependencies, I suppose. So let's go back to the cargo.toml. Oh, it's here. Request. We might need hyper too, I suppose. This has a lot of like... Oh, what happened? I think this had a lot of like sibling dependencies or something. No certificate in the root, no identity in the root. Request. Oh, weird. You know what? Oh, request here too. I'm gonna just straight up copy all the dependencies. Oh, we have to add in some features. Okay. Really? I'm gonna do everything. Dependencies and everything, and dev dependencies and build dependencies. And we'll pair back as we go. Okay. Failed to read, cargo, blah, blah, blah. Oh. Docs does not include derive. Feature docs includes derive. Okay, we don't need docs then. Is that it? I think that's it. Pair back some build dependencies. I think we need the dev dependencies. We're gonna get rid of that and that. We're gonna keep dependencies and get rid of the docs. Okay. Kubelet derive cargo. Where's the kubelet derive? This is a dependency. OCI, distribution. Okay. Oh boy. Okay. Okay, is this just gonna blow up again? Come on, you can do it. Yeah, same deal. We need something, something related to Kubernetes TLS, or something TLS related. And I don't know what that would be. Okay, so blah, blah, blah. That's fine. Kube, Sir derive, Sir JSON. We've got this good stuff. And this. Okay, let's start with this. Let's just start with this. I think that stuff is getting really complicated. The spray and pray didn't work. Didn't work, everybody. Spray and pray did not work. Okay. Let's get a baseline at least. And get away from those TLS errors. Because those are brutal. I don't even want to start to deal with those. Okay, we're down to 3. Better. Okay. The trait bound, date time, blah blah. That's gonna be, no, that's in Kube again. External location for Kube. Kube is the Kubernetes library for writing controllers. Kate's Open API is useful for working with existing Kubernetes resource types, but we don't need it. Okay, cool. That's great. So Kube is just for the client, I guess, and Kate's Open API is the native data types. So fine with me. Kube does not exist. API object. Kube does not exist somehow. Por qué? 0.14. What are they doing in here? Kube equals. Default features false. Let's try it. Actually, crates, and we'll check out what Kube says. 0.43. Oh, 0.43. Let's see if that works. Seems like a big jump. That's back to Open API, blah, 0.42. We're gonna try this. We're gonna try this. See if that works. Once again, we're in dependency hell, just like in the Go world when it comes to Kubernetes. Okay, come on, come on. You got it. You got it. Come on. Bringing in the big old Open API again. Okay. Oh, this is in our code. Okay. That's great. Okay. So, do we have just a client? Yes. And void. There's no void. Let's see if we can find if there's a void somewhere else. Kube API docs. Oh, maybe Kate's Open API has a void in it. Maybe. Let's see if we can check out type definitions. Result. Where was it supposed to be? API void. Structs, blah blah blah, enums, traits, nothing. And this thing says that void is supposed to be here somewhere. Kube API void. Well, it's not. It's not there. Sorry to burst your bubble. Neither is raw API. Let's see if we can do one of this. Just straight up unit. And in the docs, we've got client try default await. Okay, and we are going to return a result. Unit kube error. Okay, and we've got our client try default. Read the environment to find config for kube client. This tries in cluster config first and falls back. Okay, that's great. Client try default. Oh wait, we need to have an async func, which means we got to bring in Tokyo. Okay, fair enough. Let's bring in Tokyo. I don't think we need the features I don't think we need any of the features. I don't think. We'll see though. We're gonna just do Tokyo version 0.2. But first we're gonna actually check out the Tokyo docs. Actually, let's check out the crate first. Tokyo main. Okay, Tokyo prelude, blah blah blah. Apparently, you just need Tokyo main. Work stealing task schedule, it's got a reactor, blah blah blah. Okay, fine. Tokyo main. O.3.4. Tokyo main. Use Tokyo prelude. Okay. Async func main. Could not find main in Tokyo. What did we do over here? What did we do in the CLI? We did something in the CLI. Macros, okay, macros. O.22.22, boy, oh boy. All right. And we needed a macros. Okay. I wonder how you figure out what the possible features are in the docs. Is there something like features? Oh. Feature flags that can be enabled. Check out our docs. Okay. Cool. Okay. I want to get more into Tokyo. I would be excited for that. So let client equals, but not today. Okay, namespace default, that's fine. Now we've got to figure out custom resources. We just use a bunch of derives, I guess. Group equals blah blah blah. It's namespaced. API namespace blah blah blah. Full spec. Working with custom resources, uses automatic code gen via proc macros. That's awesome. Okay. And then you got kube, group, version. Okay. Excuse me. Oh, wow. And you get watchers and everything. Okay. Wow. A reflector is a watcher with a store. Okay, that's great. A controller is a reflector. Wow, I can refactor this and make it way better. That's great. Okay. So we're going to do kube derive custom resource. Is that available? There's no kube derive. I think we maybe need a feature for that. Kube derive. Kube dash derive. Okay. Oh, you don't. Let's see. I don't know. Rust client, blah, blah, blah. More of a generic Go thing, blah, blah, blah. Okay. Okay, okay. The features are available. Where is kube derive coming from? Modules, blah, blah, blah. Kube. Derive.custom resource. Kube. Can we do just kube? Oop. And then we need a custom resource. Unresolved import. What are we doing here? Oh, kube custom resource. Is that a thing? Kube underscore derive custom. Well, okay, let's do this first. And then we've got a group. That's fine. Group equals kda.sh. Foo, blah, blah, blah. Kind equals app namespace. How do you get the macros in here? Derive macros. Kube custom resource. That is so weird. Just give me a second here. There's something I'm missing here. Clearly I'm going way too fast to figure it out, but clearly there's something I'm missing here. Kube underscore derive. Oh, it's there. Okay. Kind must not equal the struct name. Let's call it scaled app. whatever. And we don't need, I don't think we need this anymore. Blah, blah, blah. Foo new. Where's foo? Oh, foo is the generated code, I guess. Okay. Option is static. The generated type foo. Oh, so we need to call this app spec. Okay. I don't think we need this. Now we've got app new, blah, blah, blah. Get rid of this. So now we're gonna do let's new app equals app new blah blah blah. We're gonna get rid of this stuff. Actually, we're gonna get rid of all this. And this for now. And we're gonna just start fresh, I guess. Get this compiling. Figuring out Kubernetes, Rust apps for Kubernetes is jumping in the deep end, it feels like. Okay. 2 errors, that's fine. Tokyo main, blah, blah, blah. Unused API object, that's fine, that's a good start. Okay. Operator can only be used in an async block that returns result or option. It does. I am returning result or option. Standard ops try, oh, okay. Try is not implemented for unit. Is that because I need to return okay? Blah blah blah. Tokyo is complaining about that result. Okay. Better. Unused client, unused namespace. Still building apparently. That's probably building the debug build. Oh. Tmux just didn't scroll all the way down. Okay, so we've got a building. That's great. App new. Takes 2 arguments. Cool. So it's generated. I'm guessing it's not gonna give us any hints. Okay. Okay, name, image. And port is 1234, whatever. Oh, this is going to be string from. Okay. Blah blah. Where do you add the namespace? Let foos API namespaced. This example creates a struct foo containing the metadata spec and blah blah blah. The generated type can be used with the kube crate as an API. Foo spec cannot be used with API. Oh, I see. Okay. So now app foo API namespace client dot clone and then namespace. Oh, it's going to be app. And API. So we've got to do something like this. Okay. And we've got app. Where is app? Oh. API app. API app. Right. Okay. Now we've got a foo client. Okay. So we'll get to the informer in a second. So we've got CRDs now. We're going to do all of our good stuff with CRDs. Now, foos. Where are they using foos? So we've got foos. Creates a struct foo. Posts the generated CRD to the CRD API. You can start using foos as a normal API object. API all client.clone. CRDs patch. Foos.clux.dev. SS apply. Alright. Let's comment this stuff out because I don't think we need it right now, but it'll be good for reference. Okay, and now let's go back. We had something talked about informer. Low-level streaming interface presents applied, deleted, and restarted events. Okay. Excuse me. This gives a continual stream of events, and you don't need to care about the watch having to restart or connections dropping. Okay, apply events, blah, blah, blah. Plain stream items a watch returns are different from watch event. If you're following along to see what changed, you should flatten it with one of the utilities like try flattened applied or touched. Okay. Reflector is a watcher. It acts on all the event K exposed by watcher to ensure that the state in the store is as accurate as possible. Cool. Okay. Controller is a reflector along with watchers that schedule events internally, send events through a reconciler. Okay. So root kind API, list params default, owns child kind API, run reconcile. So I get it. I'm gonna need to see some examples though, and I'm hoping that maybe there are examples in here. Config map gen controller blah blah blah. Here we go. Error. Here's a nice. Here's a CRD. Okay. Object owner to reference. Object meta. Owner reference. Blah blah blah. Okay. Reconcile. Whenever our main object or our children have changed. Contents insert. Config map namespace. We are trying to put a config map in or something. Let's see how we set it up. CMS. CMGs. Okay, so we've got a config map generator. That is the CRD. We want to list the default list params, I guess. Blah, blah, blah. controller, kube runtime controller. Okay. Let's go and create that. Let's do the whole thing. Down here. Controller new. We need to create an API for apps, which we did here. Okay, and now we've got app client. List params default. Okay. We need to grab list params. Where are you, list params? I'm just gonna get rid of this. We don't need this now. API list params. Okay. Kube API. All right. Oh boy. Okay. So we've got our controller. We're creating it now. Owns. So let's go in here and figure out what owns means. Modules. Is it under controller? Kube runtime controller. All right, so we probably need to do kube runtime. I guess we need to do kube runtime. Okay, controller, and here's a controller. Okay. Controller new. Create a controller on type K. Owned API. Configure list params and API so you can only reconcile events in the correct API scope or list params subset. Okay. Indicate child objects K owns and be notified when they change. This type child must have owner references set to point back to K. You can customize the parameters used by the underlying watcher if only a subset of child entries are required. The API must have the correct scope. Okay. So I am assuming this means we need to own a bunch of stuff. Because the app needs to own deployments, it needs to own services, it needs to own all kinds of crap. So, yeah, let's see what we can do about this. So, there's a API : Alright, so let's start with deployments. API deployment, API namespace, client clone, and namespace. Fine. I can't find deployment. That's because I fucked up. Okay. Hey, what up, Rockerboo? Am I getting owned with my owning? I was getting owned. I'm starting to own now. Starting to own. I get this whole Kubernetes API thing better. I don't get it. I get it better. So yeah, last time 95% owned. This time 50-50. I'll give it, nah, that's a little generous. 60-40 owned to not owned. Next time it'll be 60/40 not owned. I'm the owner now. The part that's hard, I guess it's two things really. It's the first one is trying to figure out the relationship between all the different Kubernetes crates. They have relationship, but they also seem to interact based on what features you turn on and off, and maybe more. I'm not sure about what else, but it's at least when you turn on different features, then different things interact differently and break in weird ways. So dependency hell, I guess. That was the first thing, and then the second, not really getting owned, but I was just getting a feel for where stuff lives inside of the Kubernetes APIs themselves. But that's going faster because it's really the same layout, I think. Same layout as the Go client library so far, at least. So that's going better. Nothing with Rust. Nothing with like core Rust stuff. No. The dependencies still, like figuring out how features work, that's still in progress. I'm kind of ignoring that until I really need to figure it out. But other than that, it's more like, so far at least, it's more like just figuring out like how to do. Right now I'm trying to do a controller for the Kubernetes client library, which is basically listening for events and allowing me to cache them automatically and respond to events and stuff. And all that's built in, and I'm trying to figure out how to do it, how to actually do a controller. So that's more Kubernetes, or at least specific to the kube crate. Yeah, so I think to get a deployment, I think I need to do that. It's up here. If this is even, oops, use Kate's open API, and it's API core v1 deployment. No, API apps. Yeah. Thought I just started Rust. Yeah, I guess I'm a quick study. But the thing is, the way that I like to learn is not to learn everything and just learn. It's like JIT. I just-in-time learn languages. So that's like for Rust, I'm just-in-time learning dependencies. I'm just-in-time learning ownership and borrowing. I'm just-in-time learning the Kubernetes API. I do read books, but it doesn't sink in until I do the actual work. So like I read the Rust, I'm 75% through the Rust book, but it's sitting dormant. All that stuff is sitting dormant. I'll at least know things are possible, and then I'll know where to go back and actually try to absorb the thing. But that's me. Everyone's different. I'm not the same as other people. I know how their learning style is. But no, I have only done like the hello world and a few like memory management exercises in Rust before I started all this. But yeah, the CLI work, that gave me a lot of just-in-time type of learning, because it wasn't this. Like this is a lot of dependencies. It's a lot of like more advanced patterns. Like I'm gonna have to do all this. This is like a chain of methods, blah, blah, blah. So yeah, that was a good like first step. And now I'm graduating into big boy land, the Kubernetes client. Yeah, initial knowledge pass. Yeah, exactly. Just to know that there's things out there that are possible with Rust, even though I might not understand them. And also obviously to know where to go back and look things up. Need to get back into it, but you've been under pressure to finish your app. Yeah, aka get paying clients. Yeah, business, man. Business. It always gets in the way of our dreams, doesn't it? All right, and I'm gonna just come on. I am gonna just put the default list params into a variable so I can just clone it. Yeah, Rockerboo, all this stuff is open source, so if you want to get into Rust, it's all there. I'll put it in here. If you want to get more into Rust and see my horrible mistakes, feel free. Or at least, if you want a project to hack on, I should say. I actually read on, I think it was a Reddit thread. Oh yeah. Any language allows horrible code. You don't know that? All languages are flexible enough to allow just awful code. But yeah, I read, I think it was a Reddit, oh no, it was a Twitter thread. I'll try and find it. I'll try to find it later on. It was saying like there's a lot of like, seemed like hardcore Rust programmers were on the Twitter thread. And they were saying like it's much better in your code base, especially if you're just getting started with Rust, or you know Rust but you're getting started with a code base, to just go through and fix borrow errors with just doing like a clone and moving it. And some others, they said some other stuff too, like just use a little bit more memory instead of like untangling your whole code base to fix one compiler error for borrow. And I liked that because like it made me feel better. You know, like you go into a new language and there's some experts and they're talking about God knows what. Made me feel better that like those people were just like, yeah, you know, it's fine. If you fuck up, just do a clone. It's only a little bit more memory. It's fine. So I appreciated that. And I am definitely embracing it. That's for sure. So owns now takes in an API for the child and list params. Okay, deployments API, default list params. The clone thing just reminded me because I wanted to pull this out, but now like this needs to take ownership of the list params, and I need to use it twice, here and here. So I don't think I have any other option besides clone it. Also with learning, doing a deep dive to smash the brain and walk away, coming back, it's all more solidified. It helps to build on. Yeah, I mean, I get pretty demotivated, to be honest with you, when I smash my brain and I don't want to come back. So I guess my challenge is I have to not smash my brain too much all at once, because then I get demotivated and I'm like, fuck it, Rust sucks, I'll just go back to Go. So I try to like, burn it. Yeah, that's the word. Yeah, burned out. So yeah, I try to not burn myself out all at once. The CLI was a pretty good brain smashing for me. And then I came back. I did a little bit of pairing with a coworker. And we came back, we figured out some more stuff with modules and stuff. It clicked a lot easier, just like you said. It clicked a lot easier because I got it. Like, I already had the foundation, I guess. It's kind of what I'm trying to say. So, should have a snake case name. Oh, snake case. Russ, you get me every time with the snake case. Okay. It's like the hardest thing for me. It's like remembering which languages have snake case, which languages don't. App client. What the hell is app client? Oh, it's just client. Expected. What? How did that not? Wait a second. What the fuck? Oh. It's supposed to be an API. So this is going to be app API, not client. App API. Okay, now deployments API. Default list params. Okay. Your goals are, don't force yourself to smash. You're not wanting. Your goals are more free flowing. Yeah. Oh, no. Didn't see the telescope. Hey, Xenu, what's up? Good to see you. Damn, Rockerboo. Damn. That is really solid. That's really solid. How you been, by the way, Rockerboo? Same with you, Xenu. How you been? I haven't streamed since Monday. Haven't seen y'all in a minute, so I hope your Friday is good. Hope your week was good too. Yeah, Rockerboo, this is solid. I like it. I really like it. Well done. Well done. Do I see the Easter egg? I see a tiny little planet there. That doesn't seem too Easter eggy. Is that the Easter egg? The magnifying glass was the egg. Where's the magnifying glass? Oh, this. This. Is it obvious and I'm just an idiot? Yeah, this is a new sun. Xenu, this is a new sun. It has an elliptical orbit, as you can see. And it's tiny. It's light years away. Oh, no way! No way! I love it. I didn't see that. That's perfect, Rocker. That's perfect. Even more well done. Even more well done. Oh, man. Yeah. You can sell ads, too. You put on the planets. This telescope logo brought to you by Twitch. This telescope logo brought to you by Bose. Nice. Well done. The video I'm doing displacement based on the image. Nice. Borderline subliminal. Yeah. Yeah, it is. All right. Where? Oh yeah, here we go. So owns. Yeah, fun to apply Blender knowledge. Yeah, I mean that's kind of the thing. You seemed like you were really cutting your teeth on Blender a lot, and like I didn't see even a little bit of the whole process, but what you told me, you were saying like, you know, it's a pain in the ass, it's really hard, I can't figure this out, blah blah, and then you roll out with this. So maybe that's the same thing. Smash your brain, and then you figure it out. Then, yeah, like you said, then you had all the knowledge there ready to go. Apply it really fast. And you don't need to go to videos. Does Blender do video? Some things are not as hard as we may think. Yeah, I would say it can be like that with coding. Like imagine you, oh, I'm just going back, like imagine pre-memcache. You don't have a cache. How the fuck am I gonna build a networked cache? And that's hard because, you know, you need to cache something, and it just, in your mind, at least in my mind, I just think to myself like, holy shit, I have to pause my real code and now go build a cache. And then, oh, and I have to maintain that cache now forever? Jesus. So once you have that, it's a big step up. Yeah, the cubes. All the cubes. Yeah. If you think about, like without Helm, having to deploy an app to Kubernetes without Helm, you have to go and remember to like write a script and kubectl apply all these different YAML files. Yeah, and that's, you said it, that's the word, abstraction. If you have the abstractions, things don't seem as horrible. Yeah, it depends on the abstraction. If you're talking about Rust, yeah, it's more complexity, but I would say the abstractions are, they're not higher level than Go because of the GC in Go, but they give you a different kind of abstraction to memory management than Go. It's for a different use case, right? So if you're talking about, I need to build Rust to build a web server, and you don't know Rust, it's harder than it seems because you got to learn Rust. It's not really hard to code it, but it's harder than it seems just because you have to learn Rust. Whereas if you're in Go and you need to build an embedded system you're trying to like program a drone, if you haven't done that before in Go, you probably don't know what you're getting into, because you have to figure out how to get a GC onto a chip. Whereas Rust, different story. So kind of goes back to best tool for a job, you know? Okay, where are we at? So we own a thing. All right, so our app is gonna own deployments. To do more, app needs to own more shit. And now we need a reconciler. .run returns a stream. Why? What does the reconciler do versus the stream? Consume all the parameters of the controller and start the applier stream. This creates a stream from all builder calls and starts an applier with a specified reconciler and error policy callbacks. Each of these will be called with a configurable context. All right, where's the reconcile app? Or app, haha, the reconcile function. You are somewhere. Okay. This is putting content generator.spec.content. Okay. So reconcile is gonna get the CRD. It's gonna create the config map. It's gonna put some data in as it. Oh, it's gonna create the new config map. API config map, blah blah blah. CM underscore API dot patch. Okay, and then this is just getting a stream. Oh, so this returns results. This gets called internally. It returns results, and then this. What is reconciler action? Blah. Reconciler action is, whoa, what? I guess reconciler action is just, oh, this returns a result of reconciler action, which means then this is the results of calling this each time. Hey, what up, wise old bird? I am building a Rust a Kubernetes operator in Rust. So if you don't know what Kubernetes is, do I have this? I do not. I need to add that to the bot. Kubernetes is a big distributed framework for running Docker containers in production over a cluster of multiple servers. So yeah, I'm actually getting sort of far with it. Let's just say I'm getting far. We'll just say that. So .run, I gotta get rid of that. And we need opaque type. Run returns the stream. I think the problem is that I don't have these. Data. Context, new state is T. Alright, well, let's create our reconcile function first. Func reconcile. Generator is going to be, we're going to call this app context, data. Where's data coming from? Struct data. Data we want to access an error reconcile calls. Okay, we'll just do that for now, because I don't know. I don't know what we're supposed to have come through there. Okay. And now we've got our error. I think that's just a kube error. Enum error. Oh, they create their own error. Okay. Sure. Oh, snafu is a nice crate, I think. We'll do that. Why not? Forget it. I don't want to deal with modularizing this yet. And snafu. Okay, we're not doing that. We're not doing that. Actually, are we doing that? Yeah, snafu has it. Okay, so we're gonna have to go and add snafu to our cargo. Here we go. Just take whatever version they're doing. It's under dev dependencies. Alrighty. Do we not? Didn't I just put that in? It's probably just slow. Oh, what does it say? Simplify. Oh, import resolution stuck. Simplify macro imports. Huh? Forget it. You figure it out. VS Code. We can pass context here, make this a little simpler. And then we've got an error policy. Triggers on reconciliation errors. Taking an error. Oh, so this is just saying re-queue if there's an error. Whatever, I'm not sure what that's going to be yet. And we've got a duration, which I think comes from Tokyo. Yeah. Do we have Tokyo in here? Yeah. Okay. And for reconcile, they are doing a thing. Where are they? Reconciler action, requeue. Why are they requeuing on reconcile? Why would they do that? Results of the reconciliation attempt. Whether and when to trigger the next reconciliation if... Oh, I see. If no watch, okay, so that's just a polar. We're gonna do 200 milliseconds. Requeue after is gonna be a sum. Okay. Yeah. The good old to-do implement. Okay. For each. Dot run. Let's see what cargo has to say. 7 errors. Alright. Use of undeclared type or module snafu. I might need to put this. I shouldn't need to do that, but I might need to do that. Info, no info. Warn, no warn. Don't need those. No for each. Found for opaque type stream. Oh, that's a Tokyo stream. The method for each exists, but the following traits were not satisfied. It doesn't have iterator. Items from traits can only be used with the traits in scope. Ah! Okay, I can do that. Hey, what up, X message? I'm building a Kubernetes operator using Rust. The whole idea is it looks for a custom resource called an app, just like an app. You specify in the YAML what container you want to run, or containers, what containers you want to run, what else? What ports they are listening on, should they have a file system, environment variables, secrets, like a couple of the basics. If you think about like Google App Engine or the new DigitalOcean thing with App Platform, they've got like, you know, a port, environment variables, maybe they give you a file system, sort of like a platform as a service, the feature set those have. So this thing is a piece of that puzzle. And the purpose of this operator is sits in the background, watches to see if there is a CRD called an app. Any CRD called an app will get a Kubernetes deployment, a Kubernetes service, a Kubernetes ingress, other stuff too. It'll get it all created for it, and then it'll maintain it. If something accidentally gets deleted, the operator will bring it back, and so on and so forth. New Rust? Oh, stop everything. I need to upgrade. No, I'm gonna read this later though, for sure. Thanks, Rockaroo. Right on. Oh shit, I actually gotta go. Let me get this compiling real quick. I think it was easy. The following trait is implemented, perhaps add a use for it. I don't think it's this. I think it's a Tokyo stream, maybe. What did they do in the example? I know you're still here, example. Oh yeah, it is futures. Oh, it's not futures util, it's futures. It's probably just the same thing. Or not. Stream. Nope. They might import, or they might add futures to their cargo.toml. Yeah, 0.3.5. They keep putting it in dev dependencies. I don't think that is gonna work for this cool cat. Okay, 4 errors. Oh, we graduated to 4 errors. Oh, it's because of future. Use futures. Stream extensions. All right. Down to 2. Info and warn. That's fine. I can do that. We're just gonna ignore y'all. And why is info and warn not available? Either request. Might be under log. I think it's log. Yeah, extern create log. And we're gonna have to add log. Where you at? 0.14.11. Report from. Let's just comment that out for now. And yeah. Good enough for now. Okay. Some unread fields, but overall, pretty good to go. Okay. We will check this in. Progress on the controller. Nice. All right. I read that. I read about the template literals this morning. That's pretty rad. Especially for like click. I wonder if the lib.ts has it, you know, like the click handlers and mouse over and mouse down and all those handlers. It'd be really nice to have this. Nice. All right. I'm going to bounce. Let's find someone to raid. Yeah. Yeah, me too. Who is on? Stephen Wolfram? Wow. Is that the real Stephen Wolfram? Like, for real?
Was gaming from his couch. Then he ate a pizza bagel and exploded tomato sauce on his pants.
Yeah.
Should have had Totino's pizza rolls, the
Nice.
poppable snack that's easy to eat. Because it's Totino's. Or Game Over. Buy Totino's and get bonus in-game content.
You know, a slate falls off the roof. A thing. I don't know. This drain pipe, fails. This piece of electrical cable fails. You gradually replace those things, and it's kind of like you're keeping the thing going for, in the case of houses, hundreds and hundreds of years. But you're doing that by incrementally fixing things, rather than by saying there's this magic thing that is a sort of self-fixing mechanism. But we don't completely know. And we don't know enough about aging
Monday,
to really be able to
Pacific.
distinguish those possibilities.
I
I think one thing that has happened is back, 30, 40 years.
Exercises. And yeah, have a good weekend. Cheers all.
There's nothing that we could figure out about it. There's no way that we can change it. It's just an inexorable thing, and that's the way it is. That's really changed. And there's a lot of study that's being done